Water is the life source that sustains all life on the planet. It is all around us and within us. It can come in very different forms of precipitation, such as rain, snow, sleet, and hail, as well as make up very different bodies of water, such as lakes, rivers, streams, and oceans. Water and everything it interacts with makes up the field of hydrology. In a more technical sense, hydrology is the study of the movement, distribution, management, and quality of water all across the Earth. According to the U.S. Geologic Survey, Earth holds around 1.3 trillion cubic kilometers of water. About 90% of all the water on Earth is salt water and therefore is undrinkable. The other 3% is fresh water. However, 79% of the 3% of fresh water that we have in Earth is locked away in glaciers and ice caps, many of which are melting into the ocean now, which is another problem for another day. Furthermore, 20% of that 3% of fresh water is groundwater, which is mostly inaccessible to us. So to summarize, 90% of the Earth is saltwater, 3% is freshwater, but only about 0.03% is readily available to us. So that's why hydrologists need to study how we can efficiently use and manage that 0.03% of freshwater for all 8 billion of us globally. The first component of hydrology I wanted to start with is soil. Soil is to water like bread is to butter. Both complement each other very well. This is because soil is a medium that water frequently travels through and over. And when we look at water within the soil depths, we refer to this as groundwater. But why exactly is groundwater important? After all, it's in the ground. Is it really useful to us? Well, as a matter of fact, yeah. According to groundwater.org, 50% of Americans get their drinking water from groundwater. Furthermore, groundwater is frequently used to irrigate crops, one specific case being the Ogallala Aquifer, which supplies irrigation to states of Colorado, Kansas, Nebraska, New Mexico, Oklahoma, South Dakota, Texas, and Wyoming. Now, I mentioned the Ogallala Aquifer, but what is an aquifer? An aquifer is an underground layer of water-bearing permeable rock that holds water. They are essentially giant pools of water that we pump out of the ground to access water. But obviously, there is not an unlimited supply of groundwater, and it takes a while for aquifers to recharge through rain and snow that infiltrates and then percolates into the soil, eventually reaching the aquifer. Anyways, back to the example of the Ogallala Aquifer. It will take about 6,000 years for the aquifer to naturally fill up again. But the Ogallala is not the only aquifer in the world that is experiencing a shortage of supplyable water. This is why it is more imperative than ever for not only hydrologists, but general people, especially farmers in that region, to understand hydrology of aquifers so that we can work together to conserve groundwater. Speaking of rivers and streams, while the two bodies of water are similar, rivers are essentially a larger path that's able to hold more water and transport that large amount of water than a stream is, but they are very similar. Anyways, a river is a natural flowing water course, typically fresh water, that usually flows towards an ocean, sea, lake, or another river. Rivers and streams often originate from various sources such as springs, melting snow, glaciers, or lakes. Rivers and streams can exhibit diverse characteristics ranging from narrow, fast-flowing streams to wide, slow-moving bodies of water. Understanding how rivers and lakes work is crucial to understanding how we can meet our drinking and irrigation needs and provide opportunities for many other activities such as fishing and recreational use. As stated before, hydrology is the study of the movement, distribution, quality, and management of water. So hydrologists are tasked with studying these components. Regarding specific jobs, hydrologists could be land managers working with farmers and power utility companies to discuss sustainable ways to manage their water resources. Hydrologists may also be tasked with traveling around a watershed or region to look at the lakes, rivers, and streams to gauge their water quality within that area. These are just a few examples, but I hope this kind of gives you a general sense of what hydrologists do. It's centered around water. Most hydrology-related jobs are found within the federal government, such as the USDA, EPA, NOAA, and other state and local agencies. However, there can still be many jobs in the private sector, specifically with agricultural companies and consulting companies. So in case you haven't noticed already, The world is getting a little hot due to climate change. And if you think of things being hot, not in like an attractive sense, you usually think of the only way to cool it off is with water and all that stuff. Because water stands in stark contrast to heat and everything. Essentially, what I'm trying to say is that with climate change, water availability and resource use is going to get scarcer and scarcer as it gets hotter and hotter, because not only is there going to be more demand for it, as we need more water to, for example, power utilities need more water to cool off their plants, or we need more water to irrigate our crops because it's getting drier and drier out. There's also more people into the world, so it's going to be a huge tug of war in terms of who gets access to water, depending on the certain region. Now, where I am from, the Midwest, we're actually going to get a lot of excess of water and stuff. And there's certain areas and regions all across the world. Bangladesh, for example, is a huge example where they get a lot of flooding, a lot of water. And that's just going to be the result of climate changes, and that is going to increase. But in a lot of areas, California, Colorado, just a lot of places out west within the United States, as well as, in the Middle East, or just other areas that are already struggling with water scarcity and water resource use, it's only going to get worse for them. And so the reason why I bring this up is because this is why hydrology is so important, because there are so many ways that we can improve our water resource use and improve how we use water and just be more efficient with it. And so in these coming times where it's just getting more and more challenging to get not only access to water but clean water, hydrologists are going to be more important than ever to help, you know, government agencies, government leaders and all that to figure it out, to figure out how we can manage all of this with all the demand surrounding it. And so that's why hydrology is such an important aspect, not only in just environmental science, but in the world. And because everybody depends on water, and everything living depends on water. That's what I would say is the most important aspect of hydrology, is because if we don't have hydrology, or if we don't look at the ways and how we can manage our water use, you know, we're going to have to cut people out of it because we're not going to be able to have enough water for everybody to go around. And so that's a recipe for disaster. And if we study through the ways of hydrology, essentially, then we can prevent that from happening as long as we also curb climate change. But hydrology is going to be a much needed tool within the next coming decades.